Hello everyone, my name is James Pruitt. This is my sixth lecture on JavaScript, and we're still working on our large integer type. Last time I described the environment model and showed that we're going to use that model um, and the principle of closure in order to abstract our our to abstract out our array of numbers, so that causing our number, our integer that we create to be constant, that can't be manipulated. So if you go to my website www.pruittmath.com and you look over here to on the right and you click JavaScript, you can download my code here, and we're going to start going through this. This is my large integer type, and let's see, I'm going over here. I'm using a different text editor because I wasn't able to get my font to work properly, to get a big enough font to see properly. So here we go. And I didn't talk about last time is this syntax right here, and let me discuss that briefly. Last time I said that we said var times is equal to function. And then we had the parameter y, and then we had some stuff here, and then we had close. So there's what's called syntactic sugars, just for convenience. Uh, 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 Programming languages have this syntactic sugar. It's nothing different than this. There's no different meaning, but it's just written differently. So you can rewrite this as, and it means the same thing, function, and then put the identifier in here after function, which is times, and then you can have the parameter, and then you can do this. These two things are are the same, semantically the same, syntactically different, and this is called syntactic sugar because you haven't done anything. No concepts have been created here. You're just for convenience. You're mucking with the syntax a little. So let's come back to my editor. I downloaded from my website this my integer data type. It's a function that creates another function and returns another function. So our integer type is going to be a function. And this is where we're going to put our information in here. So I have the radix, which is 2 raised to the 26th power, is going to be kept in here. The number, this is a constructor for an array, and that constructor has nothing in it right now, but we have an array here. Here's my negative, and if that's true, that means my number is negative. So my array is going to only have positive numbers in it. If negative is false, it's positive. This is just temporary variables I use for my computation. This is not really going to have anything to do with the state of the system. This is just for my initialization. So when we call this function integer, and we're going to pass in an initializer, some value we're going to use to construct. So my integer here, my program here, is going to have two parts: the construction part and then the actual function. And I'm not going to allow you to update I'm trying to, what is it called? A setter. There's no setter, so you're not going to be able to. Once I initialize these values, they're going to be fixed, and you're not going to be able to change them. So you can't use this function that I'm going to pass back to you to update these. All this function that I'm going to pass back to you is going to do is provide information. So if you come down here to where I have, let's see, hold on 1 second. When I'm returning this function, the way you use this function is you pass in a message, and it returns information. So if the message says radix, it returns the radix. If it says digits, it returns number, the length of the array, how many digits you have in our array. If type, it's going to turn integer. If you put toString, it will convert this number to a string, which is very convenient for troubleshooting. It's not convenient for computation, but it's good for troubleshooting. Or if it's a number, you can say which one. So if it's the the first, you'd put in 0. If I put in 0, it will return the least significant digit. If I put in 1, it's the digit next to 0. So it's going to be 2 to the 26th place. Or if I put in 2, it's 2 to the 26th squared place. So that's the function that I'm going to return. And back up here to the top, we'll go back to the construction. So I'm going to have an initializer come in. And there's an operator in JavaScript called type of. And all of this syntax comes from C. So the type of doesn't, but this operator type of will return a string that identifies what kind of value you have. So initializer is a value. That's what you pass in. And type of will return a string, depending on a string identifying its type. And switch is the same switch you'd use in C, except that in JavaScript you can use any value here, I think. I have to look that up. I'll get back to you on that. But I'm using strings. You definitely can use strings or numbers. You might be able to use any value. I'll look that up and get back to you. Okay, so we're going to handle the case when our initializer is a number, our initializer is a string, or our initializer is an object. And one of the things about programming you want, one of the important things about programming, the thing you don't want it to do is to, when something goes wrong, you don't want it to continue to run. You don't want it running with bad information. So it's best if something goes wrong to terminate your program and then track down what caused the error. So all through here, we're going to be checking for errors, and I'm not going to describe too much the error handling mechanisms that JavaScript has. Basically, it is you can throw when you want to raise an error, and you can throw any object. And this is a constructor. New error is a constructor constructs an error object. You can use you can throw a string with a message, but error takes a string as a message. And that's just going to terminate my program. When I have this stage, I say something's went wrong, so I want to terminate my program. And I want to go, and there's a principle, I want a tautology, and it's, this is, efficiency. Let me double check. Efficiency. Let's see if I can spell tautology. Okay. So. Efficiency, this is called a tautology, and I thought I spelled it something. Efficiency is important when it's important. And basically what I mean by that, I mean that when you're programming, you don't worry about, when you first start out, I don't worry about efficiency. Granted, if you're an educated person programming, educated in programming, you know that certain algorithms are faster than others, and you choose those well-documented algorithms before you choose the slower algorithms. You're not going to be stupid. But when you're programming, efficiency is the last thing you consider. You just want to make something as clear and concise as possible and that works. And if after you've built it, it goes so slow that it's annoying or that it's not effective as a tool, then you go back and you worry about efficiency. That's when it's important. When your software is so slow that it's impeding your experience with it, or it makes it uncomfortable, then you go back and you work out efficiency. So efficiency is not important until it pops up its head, until you notice. When you notice that your software is going so slow, then you go back and worry about it. So we're not going to worry about efficiency. Let's see what we got here. here. So back to my program. So we have three different things. We're going to have a number, we're going to have a string, and we're going to have an object. So we do the type of operator and it returns a string, and on this switch statement, the cases are what you're matching. So you're matching. So if this value that type of returns is equal to number, it's going to call this case. And break is going to break out of the switch statement. So if you didn't have the break, you'd fall through and continue doing that code in this case statement. So on this one is a number, and it's a floating point number. So basically, we want to do a lot of checking. We want to use this this constructor to check that it's properly formatted. And what we'll look here, and we'll see, first thing we'll check if it's an integer. If it's not an integer, we want to throw an error. So how we'll do that is we'll say initializer is not equal to, that's the not equal to sign, and you can do exclamation point equal sign, single equal sign, but the double equal sign, what that does is there's no type casting. So if the data types are not the same type, with this two equal sign, that's going to return false or true. It means they're not equal. They don't have the same type, they're not equal. But if you only had a single equal sign, it will try to change one type to another to make them have the same type and then compare. And I don't want that. So basically what this says is if these have different data type, then they're not equal and it's going to return true. Okay, if you have a single equal sign, it means that if I can typecast one to another, then I can test them. For instance, you might be able to change a string to a number and compare the numbers, but we don't want it to do that. So if initializer is not equal to the floor of the initializer, then it's a decimal. It has a decimal point. It's a floating number, and we want to return error. We want to stop the program. If right here, also if the absolute value of initializer is greater than or equal to math.power 2 raised to the 52, we also want to throw in an error, because we're trying to make this equal, because if math is greater than 2 raised to the 52 power, then we'll have to have three, we'll have to have at least, you have to have more than two elements in our array. You have to have a 0th place, and you have to have a 2 to the 26 power place, and you have to have 2 to the 26 to the 3 power place if this is true. So that just causes some confusion. So we're going to make sure that our number is less than 2 to the 52 if we're initializing our number with just a floating point number, a single number. And this is just to make my life easier, to put some great constraints on the input. So if that passes that if test, it doesn't throw an error. We check to see if initializer is less than 0. If it's less than 0, we set negative equal to true, and initializer equal to the absolute value of initializer, so we make it positive. Okay, then we come down here and we say that temp is equal to math.floor initializer divided by rate x. So we're going to divide our initializer by rate x and take the floor of that, and that will give us our 2 to the 26th place. So if temp is not equal to 0, our 2 to the 26th place is equal to temp. Else we're just going to take the remainder of initializer, mod out rate x, and that's going to give our 1's place. And that's it for this number type. Next one we'll go on to the string. It's the most complicated of the ones. So I'll do that next time.